Welcome back. Welcome back. One of my favorite chapters, chapter 4. There was no math in this chapter. This is where we got into sampling and experimentation. So there's a ton of vocab here. I'm going to try to go through it relatively quickly with you and just give you a quick overview of this section. So here goes. We talked about identifying population in a sample, identifying a voluntary response, convenience samples, how those are bad, and then how to do a simple random sample, either the HAT method or using paper or technology or table of random numbers. And we talked about stratified and cluster random samples and undercoverage, non-response, and response bias and wording bias. So here it goes. If you try to sample the entire population, that is called a census. Otherwise, we just take a sample, a subgroup of the population. And the idea is you take a sample to learn about the population. So then we talked about a couple bad sampling methods. One being a convenience sample. That is a bad sampling method. In essence, you're just sampling people that it's convenient to sample. People right in front of you, people that work with you. Okay, they're not necessarily going to be representative of everyone. That's why it's bad. Bias is if we consistently underestimate some value. So if I am estimating somebody's height and I only go to like the basketball team and the volleyball team, they're probably going to be taller on average. If I'm on those teams, that's a convenience sample, that's bad. Voluntary response sample, that's what it sounds like. You volunteer, you choose to be part of the sample. So click here online, fill out this poll, call in. You're at Wegmans, fill out this card. How did we do today? People are choosing to be part of that sample. And people that typically choose are people that have strong opinions one way or the other. That's going to lead to bias. Then we got into, okay, well, there that goes. How can we do some good sampling? Well, the way that we do that is through random sampling. And we talked about random sampling just makes chance a part of the process. So we talked about a simple random sample. In essence, every group has an equal chance of selection and every individual. And I just want to give you this. Let's do something simple here. All right, say we have a population of 9 students. Here are the 9 students. And say I'm selecting, I want to do a simple random sample of 3 students. That means any group of 3 could be chosen and any individual has an equally likely chance of being chosen. So if I just put all their names in a hat and pick 3, I could literally get any 3 of these 9 dots. However, if I say I have to pick one person from the first row, one from the second, one from the third, then I might get that as my sample, but it would be impossible to get all 3 people from the first row. So this would be an example of a sampling method that is not a simple random sample. Okay. All right, so then we went on with like how to do random samples. We can do them with technology. Just give each person a number 1 through n. Say there's 100 people, and then just put that into technology and randomly generate n. Like say I want to sample 15 people, 15 different numbers. Different because I don't want to choose the same person twice. You could do random integers on your calculator. That's not going to help you on the AP exam. We use the table of random digits. So maybe I assign everybody a 2-digit number, 00 to 99, and I go until 5 people are selected. So 19, student 19, 22, 39, 50, 34. Boom, that'd be it. I'm ignoring repeats. Don't select the same person twice. So that's how to go through that. We did this a little more concretely. There's examples in section 4.1 if you want to see those. Then we talked about the HAT method, and I don't actually see that in the book, so let me just make this very clear. The HAT method. There's really, I think, 3 steps to the HAT method. Let's say we're dealing with people, so assign each person a number. Write the numbers on identical slips of paper. Put into a hat in mix, and then select one at a time without replacement. That's the deal. Okay, that's how you do it with a HAB method, and then the ones that you select, that's going to represent your sample. Okay, then we went on to two different types of good sampling methods that do involve a simple random sample. The first being a stratified random sample, and this is where we did the Justin Timberlake activity. So we had all these fans at his concert. So say here's the stage, and here's here's JT. Woo! Okay. So a stratified random sample, the strata, we want them similar based on some characteristic that we think is going to influence people's responses. So stratified might be I stratify by the row that you sit in. If you sit closer to the stage, you're probably going to enjoy the concert a little bit more. So then I randomly select, say, one from each strata. So I get this one, and this one. So those would be my strata. So I'm doing a simple random sample within each strata. And then cluster was the other type that we talked about. And that's basically just done on convenience. So you're classifying the population into groups that are located near each other called clusters. So imagine we go to the lunchroom one day and we just section off the cafeteria into different sections. Like you're sitting in the booths or you're sitting at the tables. Okay. And then I'm going to randomly select either the booths or the tables. And then I'm going to sample everyone in that cluster. So everyone sitting in the booths. Okay. So that's cluster samples versus stratified random samples. So that's the difference there. This gets into that. Inference. Inference is just a fancy way to say conclusion. So basically we want to know what conclusions can we draw when we take these samples about the population. If they're bad samples, we can conclude nothing. If they're good samples, then maybe we can start concluding to a larger group. What can go wrong? Undercoverage. If your sample is not representative of your population, it suffers from undercoverage. That's bad. That's going to lead to bias. Non-response bias. This is not to be confused with voluntary response bias. Non-response bias, people are chosen for the sample. You're chosen for the sample. But then either we can't contact you or you refuse to participate. Where voluntary response sample means you choose to be part of the sample. Okay? So anytime they ask you about bias, make sure you include the direction. Like it's going to be an over or under estimate. It's a little subjective, but make sure you do include that because they're not going to explicitly say, what direction do you think the bias is? The bias is. Non-response bias. Wording. Okay. Response bias. We did the question in class with the Boy Scout. Like maybe his name is Peter. I'm not sure. He's going around his neighborhood like, do you support the Boy Scouts? And he's wearing his uniform. And we said the issues were he's wearing his uniform. So people are going to be kind of like feel bad. They don't want to say like, no, I don't. And he's going around his neighborhood so people know him. So that's like response bias. Anything that the surveyor is doing to impact the results. It could be wording bias, the way that a question is worded. For example, do you like the class AP Statistics versus AP Statistics is the best class in the whole wide world. Do you like the class? Okay, something cheesy like that, but not the best example. But you get the idea. You can kind of force people's hand to answer a certain way. All right, so that's section 4.1. A lot of vocab that goes into this section and this chapter in general. Hopefully this was informative.